Okay, in this video, we'll talk about parallel and perpendicular lines and how their slopes are related to each other. So let's just take a look at the graphs here. I mean, you can look at those two lines that are graphed in the first set of coordinate axes, and you should be able to see that they do look fairly parallel. Now, if we were to go ahead and calculate their slopes, the one on the left, we're going to go down 1, 2, 3 over 1, 2. So remember, down 3 means negative 3. Right 2 is over 2. So the slope would be negative 3 halves. Then let's look at this other line. We go down 1, 2, 3, right 1, 2, and so again, we have a slope of negative 3 halves. And that tells us something very important. That tells us that when two lines are parallel, they have the same slope. So let's confirm this, look at a couple more examples. As we go from left to right here, we're going to climb up. I always move up first. So 1, 2, 3, 4, and right 1, 2. That means we have a slope of, well, since we moved up, it would be positive 4 over 2, which is 2. Then for the second line, 1, 2, 3, 4, right 1, 2, and so again we have a slope of 4 over 2 is equal to 2. So once again, the parallel lines have the same slope. And we'll take a look at one more example here, and let's find a different color. So we always climb first, rise over run, and left to right. So up 2 over 1, 2, 3, 4, 5, 6. So m is equal to 2. Since we rose, we went up. 2 over 6 is 1/3. On the other line, climb up 1, 2, right 1, 2, 3, 4, 5, 6. And so we end up with m is equal to, again, 2 over 6, which is 1/3. Showing again that two lines that are parallel have the same slope. What this also means is that two lines that have the same slope will never intersect, or since they never intersect, they have to have the same slope. All right, let's go on from there. And the next thing we want to talk about are perpendicular lines, or the next thing we want to talk about is perpendicular lines and how their slopes are related to one another. So you may not be able to tell, these intersecting lines all appear to be intersecting at right angles, but it's hard to tell because they're not horizontal and vertical, and so it's not necessarily easy to tell. But we're going to assume that they're perpendicular, and let's look at the relationship between their slopes. So on the line 1, and we'll call this line 2. Then the slope of line 1, we're going to go down 1, 2, 3, right 1, 2. So m sub 1 would be negative 3 over 2. Now let's take a look at the second line. We'll do this one in blue. So we start at this point, rise 1, 2, 1, 2, 3 to the right. And so the slope of line 2 is going to be up to right 3, which is 2/3. Notice anything about them? Well, their slopes are reciprocals. One is flipped. The 3 halves gets flipped to become 2/3. But it's not only a reciprocal, we also see that their signs are opposite. So we say that perpendicular lines are opposite reciprocals. Opposite has to do with their sign, and reciprocal means flipped. All right, so the sign has to be different, and they will also be flips one of another. So we'll go on and take a look at the second pair of lines here. First line, we're going to go down 1, 2, right, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 7, 8. And so we have, this would be L1. M1 would be down 2, so negative over 8 is negative 1/4. And remember, to flip that, we would get 4 over 1. Change its sign, we would get positive. So the second line should have a slope of 4, positive 4. So let's see if that works out. We start at a point 1, up 2, 3, 4, right 1. So M sub 2, the slope of the second line is 4 over 1, which is 4. And again, we see that the slopes are opposites and reciprocals. Okay, we'll take a look at one more example here then. We have let's call this line 1, and we start, climb up 2, so we have a positive 2, 1, 2, 3, 4, 5, 6. So we have M1 is equal to up 2 over 6, which is 1/3. What that tells us then is that the line that is perpendicular to that should be flipped, 3 over 1, which is just 3, and then have an opposite sign. Since the slope of the first line is positive, the slope of the second line will be negative. And let's see if we do indeed get that. So we start at a point on the left. We're going to climb down 1, 2, 3, right 1. So if this were L2, then our slope for line 2 would be negative 3 over 1, which would be negative 3. And so the moral of the story is, two lines that are parallel have the same slope. Lines that are perpendicular have slopes that have opposite signs and are reciprocals of one another. Let's look at some examples. In example 4, we want to find the slope of the line that is perpendicular to the line L that passes through 4, negative 6, and negative 3, 5. So we're not looking for the slope of the line passing through those points, but we're looking for the slope of the line that's perpendicular to the line that passes through those points. So once again, I'm going to label x1, y1, x2, y2. And so first what I want to do is calculate the slope of the line that we're given. So m is equal to y2 minus y1 over x2 minus x1. y2 is negative 5 minus y1 is negative 6 over y2 is negative 3 minus 4. And so we're going to get negative 5 plus 6 over negative 3 minus 4 is negative 7. Once again, you can do this all on your calculator as long as you put the numerator and denominator in parentheses. That way, once you set it up, you can make sure that you won't make a mistake on the calculation part after you've set up the formula. Negative 5 plus 6 is positive 1 over negative 7, which gives us a negative 1 over 7. So what would the slope of the perpendicular line, or the slope of the line perpendicular to that line? It would be opposite sign, so positive, and reciprocal. 1 over 7 reciprocal is 7 over 1, which is simply 7. Okay, so you do one of these. You can read the problem, work it out, or pause the video, read the problem, work it out, and then come back and check your answer when you're done. If line L passes through these points, 5, 0, x1, y1, x2, y2, and I'm going to calculate my slope. M is equal to y2. That is the slope of the line that passes through those 2 points. x2 minus x1. y2 is negative 2 minus y1 is 0. x2 is 6 minus x1 is 5. And so negative 2 minus 0 is negative 2. 6 minus 5 is 1. So that gives me a slope of negative 2. The slope of the line perpendicular, and I use that little perpendicular symbol there, it's just going to be the opposite sign. So since the original slope was negative, our slope will be positive. And if the original slope was 2 over 1, we're going to be 1 over 2. All right. So let's go through some more examples of this. Find the slope of a line that's parallel to this line, to these two lines here. So x1, y1, x2, y2. We're going to calculate slope. M is equal to y2 minus y1 over x2 minus x1. y2, sorry, there should be a 2 here, is 3 minus y1, which is 7, over x2, which is 24, minus x1, which is 6. So y2 minus y1 is going to give me negative 4, and 24 over 6 is going to give me 18. If I simplify that, again, you can use your calculator to do all of this for you. If you want another example of that, let's go ahead and take a look at it here. So we'll have the calculator go all the way back to the beginning. We have, but you have to remember to put your parentheses around the numerator and the denominator. If you don't do that, you're going to get an incorrect answer. So parentheses 3 minus 7, close parentheses, divided by, open parentheses, 24 minus 6, close parentheses, and we get negative 0.22222. You want to see what that is as a fraction? Simply go math, 1, enter, and we get negative 2/9. So what is the line? I'll use these little parallel lines here. The line that's parallel to that, or any line parallel to that, will have the same slope, negative 2/9. Go on to the next example. M is equal to y2 minus y1 over x2 minus x1. And we'll label our points x1, y1, x2, y2. And plugging in, we get negative 10 minus negative 5. Put it all in parentheses if you want to do this on your calculator. Denominator, 17 minus 32, close parentheses. And when I put that into the calculator, I have my whole numerator wrapped in parentheses, negative 10 minus parentheses, negative 5, close parentheses, divided by open parentheses, 7 minus 32. I can go directly to math, 1, and then enter, and I get a fraction of 1/3. And that means any line that's parallel to that line will also have a slope of 1/3. Okay, in the next two problems, we want to find the slope of a line that's perpendicular to the line that passes through those 2 points. So to save a little time, I've labeled my points, plugged in my values, typed them into the calculator, putting parentheses around the numerator and denominator, and I get 0.6, which math, fraction, enter, gives me 3/5. So the slope of a line perpendicular to that line will be the reciprocal, 5/3, opposite sign, negative 5/3. Let's go on to the next. I label my points, set up my equation, plug in y2 minus y1 in parentheses over x2 minus x1 in parentheses, plug it into my calculator with the numerator and denominator both wrapped in parentheses, and I get 0.5, which we know math, fraction, enter is 1/2. And so the line perpendicular to that line will have a slope of opposite reciprocal